All right, welcome everybody. Let's do this. So lesson 15, part 2, even and odd functions. Let's observe the following. If we have this graph over here, by now we should be okay with which graph this is. This will be some x squared. And if we look at this graph, what's the dance move? It's x cubed. What I want us to find is there a type of symmetry within the graphs? So take a second, pause the video. Do you see some sort of symmetry? Okay. If you're coming back to the video, let's take a look at this. If we have x squared, notice that whatever is on this side, it's reflected over to this side. So we call this type of function even, okay? Because there's a symmetry with respect to this y-axis, okay? Here, this has a symmetry over the origin, right? If there is a mirror reflection from here to here. And one thing that's pretty nice is we call this odd if it has this type of symmetry, that if I put my finger right here, and what you could do is you could draw this graph. If I put my finger right here, notice I'm going to turn the paper 180 degrees, and bam, I get the same graph. Watch, I'll do it again. If I do another 180 degrees, look, nothing, it won't change anything. And this is what we call an odd function. This is what we call an even function, okay? And let's just observe this, and let's have this in our notes. If a graph has a reflection with respect to the y-axis, we say that it is an even function. Notice that this graph has a reflection over the y-axis because whatever we have on this side is the same on this side. The same with this graph, the same with this graph, and the same with this graph, right? And if we look here, if you're clever, this should be, like negative x squared plus some c or something. What's the graph for this equation? It's absolute value x. This one, they don't really have. We'll talk about soon what these are. Let's look at the next one. Here, if a graph has a reflection with respect to the origin, we say that it is an odd function. So the same idea that I had with taking your finger here and being able to rotate it, notice you get the same pictures, right? This is how we know if it's odd, if there's a reflection with respect to the origin, with the center of the graph. And the same thing will happen for this one. If you want, have this in your notes, draw it out, and have fun. Like put your finger right here. Notice if I rotate it 180 degrees, you get the same graphs. This graph, I didn't draw it so well, but you get the idea. So these are examples of odd functions. Here, if a graph does not have a reflection with the y-axis or the origin, then it is neither an even or odd function. So graphs like this one for example, there's no reflection with the y-axis and there's no reflection with the origin, right? If I turn it upside down, they're two completely different graphs. And this one too. And if you think, oh, Mr. G, it looks like it's symmetric with the y-axis. It's not, because if this is -3, then this has to be 3. Or if this is 2, then this has to be -2. There has to be some sort of mirror. And these are not odd or even either. So what I want you to do is take a second on this worksheet, just complete 1, 2, 3, and 4, and depict whether it's odd, even, or neither from the graph. And what I'd really like you to do is take your calculator. I want you to try and create a polynomial that is an even function. For example, if I were to, I just know off the top of my head, I know that something like x squared plus 4 is going to be an even function, just by the way it looks. So let's just take a look. Let's say if I just take a guess. If I go to my calculator, I hit y equals, I hit x squared plus 4, and now let's zoom in a little bit. And if I hit graph, notice that here, this has a reflection with the y-axis. So I created a polynomial that was an even function. What I want you to do is try and mess around with the calculator, create an even function. Create a polynomial that is an even function. Create a polynomial that is an odd function. Create one that's neither. Okay? See you.